workshops. I'm Kathy Prudhomme, the Community Outreach Program Manager with NFPA's Wildland Fire Operations Division. This session is being recorded and will be part of our online course and education resources section on the firewise.org site. Today's topic is understanding how embers ignite roofs in a wildland fire and how to make it more survivable. The topics that we're going to cover are part of a whole range of ideas that were suggested by participants in the more than 1,050 Firewise communities throughout the nation. I'm just going to take a minute to go over the format. Steve Quarles and I are going to talk about 5 topics related to wildfires, roofs, and research. And then Steve's going to answer 4 questions submitted from Firewise community residents in Colorado, Florida, and Idaho. We're really honored to have as today's Ask an Expert guest presenter, Dr. Stephen Quarles, Senior Scientist with the Insurance Institute for Business and Home Safety at the Research Center in Richburg, South Carolina. Steve joined the IBHS Research Center team in 2011. Prior to joining IBHS, he worked for the University of California as a cooperative extension advisor. During 2007 and 2008, Steve worked part-time with the California Office of the State Fire Marshal, where he developed, coordinated, and served as an instructor for the educational program related to the Wildland Urban Interface Building Code and Standards. So it's our pleasure to have as a guest presenter today Dr. Stephen Quarles. And Steve, thank you so much for joining us today. We're honored to have you with us.
Thank you. Thanks.
So what we're going to do first is I'm going to ask Steve some questions, and then he'll provide the answers to those. Steve, we all know wildfires have destroyed thousands of homes throughout the U.S. in the last couple of years, and many of those losses can be attributed to embers igniting roofs. Will you explain why roofs are such a vulnerable area during a wildland fire?
Sure. Well, thanks, Kathy, for the invitation to be here today and for the opportunity to speak to the group. Roofs are a relatively large horizontal surface covering the part of the house in which we live, and as such, it can collect debris, vegetative debris such as pine needles and leaves, and during a wildfire can also collect wind-blown embers. These are also called firebrands. So the roof itself, the sort of the red circle part of the slide you're looking at right now, sort of here, and the part of the roof that abuts other parts like this dormer that we see here or the skylight that we see here, they need to resist this ember exposure and flames that might occur from the debris that might be ignited by these wind-blown embers. So that's why the roof is vulnerable, and that's what it needs to resist. So in the next couple of slides, we're going to look at these 2 areas separately. So we have a way to evaluate the performance of a roof covering. That's the red circle part that we saw in the last slide. And we do that by conducting a standard test which we expose the roof to these burning brands. And there's 3 levels of brands, 3 classes of brands, with the class A brand, which is the largest one, 12 inches by 12 inches square, and the B and the A brand have a 3-layer sandwich construction, with the middle layer being perpendicular to the top and the bottom one. So Class A, 12 inches by 12 inches, Class B, 6 inches by 6 inches, and Class C is roughly the size of an ice cube. So the next slide shows a test in progress. So we have a Class A brand, or burning brand, on top of the roof covering, and we are essentially waiting to see whether the fire on top of the roof will burn through the roof covering into what would be your attic space. So in the lower right-hand picture, we see that flames are coming through a joint in the sheathing, indicating that as built, this roof covering is not a Class A roof covering. It is something else, maybe a B, maybe a C. But as it's built, it's not an A. So we wouldn't be able to call this a Class A covering. And this inset picture here is just to show you that this whole test is done in kind of a wind tunnel apparatus. So It's a 12-mile-an-hour breeze blowing over the roof that we see here and the burning brand that would be positioned where it's shown and in this location. So regarding still with the roof covering itself, the roof covering can have a fire rating based on the covering alone, or it can have additional materials underneath the roof covering that help it get its Class A rating. And so this slide here shows two kinds of ratings where it's Class A, but it gets the Class A rating because of additional materials. The upper left-hand picture shows a fiberglass gypsum product that is installed underneath this fire retardant treated wood shake. So as an assembly, this is a Class A, and the lower right is an aluminum metal roof that has an asphalt composition roll roofing product installed underneath it. So notice in this case it's a Class A brand, melts the aluminum roof pretty quickly, and so for the most of the test, the Class A burning brand is sitting on top of this asphalt composition roll roofing product. And this is again is by assembly Class A rating. So this is the roof itself. We're going to show a couple of pictures of the edge effects that we talked about, where the yellow boxes where the roof abuts another material. That material can be air. So here we show a non-combustible paper tile roof, a gap between the covering itself and the roof deck. When open, birds can fly up in here and build nests, or debris can fly blown up in there, and during wildfire smoke and embers, the birds can readily ignite that fine fuel, bird nest, or the debris, and in essence bypassing the protection offered by this non-combustible roof covering. So in order to guard against those things happening, we suggest doing something called bird stopping, where you plug the ends, in this case it's with a mortar mix, so that birds can't go up, debris can't go up, and embers can't be blown up underneath the covering. Therefore, you get the protection offered by this Class A roof. The lower right-hand picture is a fire from Nevada a couple of years ago, where embers entered through openings between this flat tile and the roof surface at the hip. And so this is just to remind us that in addition to boxing in at the end, at the eave, to also do so at the hip and at the ridge. The next slide here is just showing a flat roof and talk about skylights. In this case, the flat roof, we have the two kinds, and the upper left-hand picture is a flat glass skylight, and the lower right it's a plastic dome type. In a flat roof, well, in general we recommend the glass type because glass is more resistant to heat than the dome type. But in this particular situation, with the debris accumulated on top of the flat skylight and not so much on the dome type, the flat glass type is more vulnerable in this location. The solution, though, here is to keep debris off the roof, and that just takes a maintenance effort on the part of the homeowner. So I think we're ready for the next question now, Kathy.
Great. IDHS has an amazing research facility, and I just have to say I'm a little jealous of my colleagues that have had the opportunity to be there to see my test. Can you take us inside the lab and share what research has shown in relationship to roofs and embers?
Sure, thanks. We'll leave it on this slide for a second just to show you what we have at the IDHS Research Center. This is a large wind tunnel facility where we investigate natural hazards generally that have a wind component. And we can simulate an ember storm in our research center by use of these ember generators. We have 7 of them here along the outlet to the wind tunnel. The guts of the ember generator is below grade in this trench, and it consists of a burn chamber and a raw material hopper. The raw material hopper feeds material into the burn chamber. There's a gas burner that ignites and burns the raw material, and there's a wind that blows up, a fan that blows wind up through the burn chamber, and it lifts the burning, lofting material up through the circuit stack and out into the wind flow of the wind tunnel. So we'll show you in the next couple of slides a couple of clips just to show you what it looks like in action. We're going to be looking at, the first clip is of a demonstration we did in November. So here we can see Embers leading the vertical duct. We've attached this lean-to structure that has a lot of combustible materials on it. We have mulch at the base of the wall, a couple of windows. We have a wood composite deck, wood plastic composite deck attached to the door, and some more materials on the rear corner to the left of the door. So Embers readily ignite the bark mulch. Fire, this is looking down at the rear corner. We're going to ignite this bark mulch also. The fire will then transfer to the vegetation. Here we're inside that lean-to structure, looking through the window at the embers coming at the window. And you can see the flames looking up a little bit at the base of the window. So we're going to ignite this vegetation next to the window. The fire is going to spread underneath the wood plastic composite deck and ignite that. And then the fire is going to spread around into this rear corner area. We have combustible siding, combustible wood fence. There's a rubber-based downspout deal here at the bottom. So the fire is going to then grow up the wall here, as you can see, spread up the wall. We're going to be putting this fire out here directly just because behind this lean-to structure is the test building that we aren't ready to burn down quite yet because we want it for our research project. So this is just an example of what Embers can do and how we can use these to evaluate different strategies to make homes safer. We're going to go straight to the next clip. The next clip, the purpose of it will be from our most recent research last fall and early in 2014, and we were evaluating the vulnerability of vents to ember entry. But here we have embers attacking the building. They're going to see views from the outside and the inside for a number of different kinds of vents. Here we're looking at a gable end vent with quarter-inch mesh screen. We varied the size of the screen, the type of vent. But right now it's quarter-inch mesh screen, gable end vent, and now we're inside the attic, and you can see the embers entering the attic space, and we're going to see a view from further back in the attic in just a second, and you'll notice that the embers that enter, they go in many directions. We need to have something in the attic space to make them congregate, let's say, and so if you had been storing boxes of clothes or boxes of this and that, just things you store up there that are combustible, those are the types of things that the embers can lodge against and ignite. That would be the vulnerability of that. So here now we're looking at the outside of an open eave, vent in an open eave, so open eave framing where you have blocking and vents in that. Here's the inside the attic space, and you notice again with this blocking that embers enter and travel throughout pretty much the attic space. This is the outside of a soffitted eave, so it's an eave where you have a horizontal member extending from the roof edge to the siding, and then you can see a quarter-inch mesh strip vent in that soffitted eave. Now we're inside the attic, not as many embers entering here. So this soffitted eave construction is a better detail for minimizing the entry of embers into the attic space. A camera view from on top of the roof, and in this case we're evaluating the off-ridge vents that you can also see. So we're going to go inside the attic here in a second and see the view of embers entering here. Again, this is similar to the open eave vent and blocking, where embers readily enter because of that perpendicular face to the roof wind flow. It seems to be the detail that allows ember entry to occur. Here we're further back in the attic space. Again, embers readily entering with this off-ridge type of vent. We looked at a number of kind of vents, and we will be publishing our results as soon as we're through with the analysis, which will occur in a few more months. So those are a couple of clips that I hope demonstrate our capabilities and some of our findings. So I think back to you now.
Thanks for that, Steve. That was awesome. In your research, great. In your research, you've had the opportunity to travel to some communities following large wildfires to examine homes that survived. Will you explain what you've learned from those sites as it relates to roofs?
Sure, thanks for the question. There have been a number of post-fire investigations over the years that have demonstrated the importance of a Class A fire-rated roof covering to the survival of a home during wildfire. My personal takeaways from the post-fire studies I've been involved with have been related to the importance of wind-blown embers to ignition and the small details that turn out to be pretty important details in terms of home surviving. Many of these small detail, important detail kind of memories that I have occurred when looking at destroyed homes and damaged homes that pretty clearly had Class A roof coverings and non-combustible siding, which really lends credence to the importance of embers that we've been talking about so far. So the slide we're looking at shows two different homes. The left-hand stacked pictures show one particular home in a Southern California fire in 2003, and the right-hand picture shows another Southern California home from the 2006 fire or 7 fire. It's often really difficult to say with certainty the exact cause of what the initial ignition was in a home that's been destroyed. This slide see here clearly shows a non-combustible roof covering, and it has a stucco non-combustible siding. So in this case, and you see a lot of green grass and non-combustible surfaces around this home, which clearly indicate that it was ember ignition of some kind. But what the initial ignition was, it's hard to say whether it was a glass breakage from radiant heat explosion of fire going up the slope, or entering embers entering at the ridge or hip, as we saw in a previous slide. It's hard to say. The right-hand picture, as you can maybe tell by the white marks on the wall, had a lot of vegetation growing up the wall, starting at the ground. So this likely scenario of ignition was ember ignition of vegetation at the base of the wall, burning vertically upward, potentially breaking glass in this window, entering that way, and then moving into the attic, either from the living space up or up the wall completely and entering in this open eaves construction that you can't really see, but which was present. So embers are critical. I think that's my takeaway from my post-fire investigation.
Steve, I've heard firefighters describe the number of embers generated at a fire as being similar to snow in a blizzard. Are there things homeowners can do to make their roofs more survivable and less vulnerable to embers? That visual example is just amazing at imagining the volume of embers generated.
Yeah, thanks. Yes, definitely there are, and I guess that's a fortunate thing that there are things that people can do to help their homes survive a wildfire exposure. The most important thing, of course, is to replace your wood-shake roof if you happen to have one, and so this slide is a picture of a home that has a wood-shake roof, and we would recommend replacement of such a roof with a Class A fire-rated roof covering. And this actually is a good example of something called what I call a complex roof, because it has a lot of locations where the roof abuts another vertical surface. Here we have a deck and and another vertical wall and this sort of split level kind of a house. So we'll come back to this in the next slide, where we see a debris accumulating on the roof adjacent to a wood shingle siding on the split level house. So debris accumulation on the Class A roof. This is an asphalt comp Class A roof. Ember ignition of this debris will readily occur. So keeping debris off the roof is a good strategy. The Class A roof can definitely handle this kind of exposure. The question is whether the siding adjacent to the roof can provide the same kind of protection that the Class A roof covering does provide. In this case, I would argue that it doesn't. The lower right-hand picture is of a 2011 study at the lab here in Richmond, in South Carolina, where we just demonstrated how easy it is for embers to ignite debris next to the siding on this again, Class A roof. So you have the siding that could be vulnerable, and also the soffit area where the dormer meets the roof covering. It could also be vulnerable to flame impingement exposure. The next example is similar to the one before. This is a chimney chase, and you'll notice that the siding comes pretty close to the surface of the roof, and so this is a situation where ember accumulation alone, without the debris accumulation, could result in ignition of this combustible material used in the chimney chase. The lower right-hand picture shows that this is the backside of cricket side of the chimney chase that had some metal flashing, and it looks like it could have been a direct ember ignition here. But because this flashing didn't tuck in behind the siding, the embers and water could have a way to get behind the flashing and between the flashing and the metal and the wood siding here. If that was the case, it may actually not be the case. It's hard to tell. But in any event, these are two examples again where ember accumulation, either directly or by accumulating debris, could ignite the combustible siding. The solution could be to replace this kind of siding locally. So it would be pretty expensive to replace combustible siding everywhere on your house, but not so much to replace it locally on this side, for example, of the chimney chase, where you would replace it with a non-combustible product. So I think we're good for the next question. No, sorry, we're not. One more. I just wanted to talk a little bit about vents as one thing you can do and one vulnerability of a home. And so here, this is the upper left-hand picture shows an 8-inch mesh screen that has been clogged with some debris. The lower right is a 16-inch or 16th-inch mesh screen that has been painted over. We have vents for a moisture management function. It just so happens to be vulnerable to ember entry. So we recommend at a maximum 1/8-inch mesh screen. It minimizes the size and the number of embers that enter into the attic space. You need to make sure that they're in a good enough condition so that they can perform their moisture management function. So where it's dirty in this case, you need to clean it, and where it's painted over, you need to replace it, and you want to repair it in these kind of locations where it's actually detached from the area on the where they attach it to the underneath component of here. So now I think we're ready to move to the question.
Great, thanks. If the participants in today's workshop were going to tackle one thing this weekend related to their roof, what do you recommend as their starting point?
So I've listed about 5 items here that the homeowner could or occupant could undertake. As you see during the course of this webinar, there's a number of things that can be done. I tried to select some low-cost items here. So remove vegetation from debris, vegetated debris like pine needles and leaves from the roof and gutters. This sort of assumes that you have a home where these things are accessible and that you are able to do that. Otherwise, you might have to hire someone to do it for you. install a drip edge, or sometimes called angle flashing, at the edge of the roof. That could be where the roof meets the fascia. We'll talk a little bit in more detail about why this is important in a couple of slides. Pruning tree branches that overhang the roof. This is a way to minimize debris accumulation on top of your roof. And then I would suggest that you survey the roof to make a note of areas where the roof is damaged. So broken tiles, detached shingles. These are places that make your roof more vulnerable. Even if it's a Class A roof, these would be vulnerable locations. And so make a list of where these are, and then you can start investigating contractors that can help you make these repairs if you're not able yourself to do it. And as we saw in the previous slide, you can inspect attic vents to make sure that these screens are appropriately sized and that they are in good repair. So these are a list of some things that you can do, and you'll see along during the course of this webinar other things that you might also do.
Well, now's the part where we get to ask you some questions. So to get us to this point, we asked members of Firewise communities throughout the nation to send us some questions that they had about roofs. And our first question is from Randy L. in Colorado. And Randy says he has a fiberglass composition roof, which seems to be okay, but he's concerned about the soffits and the fascia. His are painted wood with no vents or openings, and he wants to know if he needs to do something about them, and if so, what. He says that they don't have trees or bushes within 10 to 15 feet. So Steve, can you give him some tips?
Sure. Thanks for the question, Randy. Looks like you've done a lot of things just right. So I'm going to just take the opportunity to talk around some of the issues you brought up. So here you see an asphalt comp roof that is in bad condition. You notice that the mineral surfacing granules have been dislodged, let's say, from much of the roof. You're exposing the asphaltic component of the roof here, unlike in this location where you actually have the granules still in place. And you'll notice also that the shingles are curled in many places. This is probably not doing a good job from a moisture exclusion perspective, and it may not do such a good job from a fire perspective either. So if your roof is in this kind of condition, this is time to replace it. Sounds like that's not the case for you, Randy. And then, so your fascia, I would think, would be most vulnerable from an edge of the roof kind of exposure, from gutters that would be debris filled and be ignited by embers, such as the upper left picture. So that's why you can see recommendations for gutter covers. We'll talk about gutter covers in a second. That are the purpose of which are to keep debris out of the gutter or to minimize the debris accumulation. The lower right-hand picture shows a couple of different things. One is a vinyl gutter that had debris in it, ignited by embers. So a vinyl gutter will detach pretty readily and fall to the ground. But while it's you do have an edge of the roof exposure, and you have exposure to the fascia. And then the gutter that we see to the right, that'll stay put if debris in it is ignited, and you'll have an edge of the roof exposure for the entire time that the debris in the gutter is burning. So for these reasons, it's another reason to keep debris out of the gutter. We'll talk about something you can do regarding that debris buildup in a second. To protect the fascia. You want to just look at the wood-based materials used at the roof edge, whether it's fascia or sheathing products, just to make sure it's in good condition. In this particular slide, we see some decayed wood sheathing. Once dried, this is more readily ignited, so a little more vulnerable to ignition than solid wood or wood-based products. So take a look at it to see whether it's in good condition there. And if you keep it painted, as I suspect you have, then that opportunity is sort of lessened. This is a picture of a gutter that has this drip edge as part of it, and with this gutter you can protect that fascia. And so you don't need to have actually a gutter that has an integrated drip edge. You can get a drip edge separately and install it separately. It just it helps protect that edge from any embers, any debris that might accumulate, and it'll protect the edge if embers do ignite it. We see here a picture of one kind of gutter cover device. There's many kinds out there. I think you need to be a little bit careful in picking. This one doesn't really do a good job of keeping debris out of the gutter. Others do a better job. Sometimes gutter covers just allow the debris to accumulate in back of the gutter cover on the roof. So it's better to accumulate there than in the gutter, but you need to be a little bit careful in terms of that strategy. And then the lower right-hand picture just shows an ember entering at the top of the fascia and edge of the roof sheathing interface. The wind just blows it in. A drip edge minimizes the opportunity for that to happen. So for that reason also we suggest this drip edge at the roof edge. So the other issue, just to be clear, Randy, when you talk about the type of eave that you have, I guess I'm assuming you have this kind of eave, the lower right-hand picture where you have a material that returns from the roof edge horizontally to the wall. This is what I would call a soffited eave. And this shows an experiment I did a few years ago that demonstrated the vulnerability of an under-eave construction to address same contact exposure. Soffited eaves, they ignite later, even if you have a combustible soffit material, and they don't spread laterally as quickly. If you have an open eave construction, the type that we see in the upper left-hand picture, ignition is quicker because heat builds up in that boxed-in area, so to speak, an open area where it's protected by the fascia, and then spreads much more rapidly laterally. So for this reason, from a flame impingement perspective, we suggest a soffited eave. And then also, as you may remember in the video clip, the vents in the blocking in open eave construction are more vulnerable to ember entry than in the soffited eave construction scenario. So we would suggest boxing in those situations to get a strip vent, for example, that you would have in a soffited eave construction just because ember entry is less. So I think overall you did a great job, but hopefully these little additional slides help you evaluate your particular condition and others also to do that with your under-eave area.
Randy's question was great. Thanks, Steve. Our second question is from Jim M. from Florida. And he wants to know, in Florida, we're building roofs, both new construction and retrofits, to meet higher hurricane resistance standards. Please describe how roofing materials and construction methods used to improve wildfire resistance are synonymous with those used to improve hurricane resistance.
So thanks, Jim. It's another good question. And as you point out, there are a lot of similarities between what we would do to help a home roof system survive a hurricane and wildfire. They're very similar. As an example, both hazards would have recommendations to cover gable end vents. Both hazards have the recommendation to install the metal drip edge that we just talked about at that roof edge area. And from a material perspective, we would recommend both to attach them well. I think that's probably more important to hurricane type exposures, but for example, with clay rail tile roofs to attach with mechanical fasteners like nails as opposed to just an adhesive, be better from a hurricane perspective. But from a fire perspective, the types of Class A roof coverings that we would recommend for fire are also good for hurricanes as long as they're attached properly. With regard to venting, there's also really good similarities in performance. So we see in this slide, we see a wind and water rated ridge vent that has this external baffle that does a really good job of keeping water out, and it does a really good job of keeping embers out also. So in our recent experiments, we tested this exact vent. You can tell where the embers struck it. And we took another similar vent and cut off this baffle, and it really made a difference in terms of ember entry potential. So this external baffle is a good design feature for both water and wind and embers. But you'll notice that this is a plastic vent, and so if you have debris accumulating against it, embers will ignite that debris, and you'll have a flaming exposure to the plastic vent, and the result may not be the same. So from an ember exclusion perspective, these things work fine. But from a flame impingement perspective, it would be a different story. So you need to make sure you keep debris off your roof because of this particular vulnerability. And then we have already talked about replacing damaged tiles and plugging ends of eaves, and in this case we also see openings in the valley of this particular tile roof. These would be collection spots for debris and also for embers during wildfires, and these openings also would make the roof more vulnerable to wind uplift loads. So both hazards would have recommendations to replace damaged tiles and to plug areas such as this so that the uplift forces are reduced and the likelihood of shingle offset and detachment are reduced. And similar to repairing this sort of partially bird-stopped opening in this particular case. So a lot of similarities, great question, and hopefully this helps answer it.
Well, I think that will be really helpful to our coastal participants. Thanks, Steve. Question number 3 is from Tom D. from Idaho. And Tom says, post-fire inspections have shown different survival rates for homes with wood-shake roofs and those with composite shingles. Can you share examples from your post-fire visits and lab work that show any difference in ignition potential for these two types of roofing materials?
Sure. So thanks, Tom. I'll stick to a couple of examples from our laboratory research because it demonstrates pretty well, I think, what we want to demonstrate here. The first slide is of asphalt composition shingle roof, and we're particularly interested in the valley where you can have accumulation of debris and ember ignition of that same debris. So we see in the upper left-hand picture where we placed the debris here, and then we ran our test. The embers clearly ignited it pretty quickly. And then the lower right-hand picture shows the aftermath. So definitely damage to the shingle, but burn through into the attic space did not occur. And that's really what you expect or want out of a Class A fire rated roof covering. But I think this also points out one thing that we should say. I think many people sometimes confuse Class A fire-rated roof covering and non-combustible roof covering. A non-combustible roof covering is non-combustible, but a Class A fire-rated roof covering doesn't have to be non-combustible to meet the Class A requirement. And the asphalt comp shingle roof is an example of that. It has combustible components in it. It just can pass the requirements of the test to be called Class A. And so in this case, you will have some damage to the roof covering, but you will not have a lost home because the fire burned into the attic. That's not the case with a wood shake roof that we show here. So in this case, it was an ember exposure of a wood shake portion of the roof covering here. And we have 5 red circles here designating either flaming combustion or smoldering combustion at these locations. The next slide will show the sheathing underneath this burning part of the wood shake shingle, the wood shake. I think it's just important to state here that you notice that the entire roof covering is not ablaze right now. So even with a wood shake roof, the fire will start small and get larger. It's just that you have all sorts of combustible things here, and without suppression efforts by either a participant or someone on the ground, like a firefighter, this house will ignite and burn down because of nothing to stop it. And we see an example of that here. So we took off the shingles in this location, and we see that at the time we stopped the test, the fire had burned through and had charred and burned through the sheathing, and you can see the burn through in this lower right-hand picture. So this would have pretty shortly burned more into the attic space and involved the house, the attic space, and then the house. So pretty clear distinction between the classic covering that we saw in the first couple of slides and the wood shake covering that we saw in the last couple of slides.
That takes us to our last question, and this one's from Bill T. from Colorado, Steve. He asks, many mountain residences in wildfire-prone areas have viewing decks as a significant part of the home, with some of those being on rooftops. How do embers ignite these types of flat surfaces, and what can be done to protect them?
So thanks, Bill. Another good question. All four of them pretty great, I'd say. So I just I'm going to clarify this rooftop deck and then talk about decks in general. It seems to me that your question could be more related to the deck on the lower right here picture, where you walk out and you're standing actually on top of the livable portion of your roof or your home in an occupied space. Or you could be walking out on a deck that would just be overhanging your property, and you'd be looking at a nice view. So we can talk about both of these scenarios. Often when you walk out on a deck that is where you have living space underneath that deck, which could be a roof type of deck, you'll be walking out onto a non-combustible walking surface, so it'd be flagstone or lightweight concrete or some such. And in those situations, your major issue is to address ember accumulation ignition potential. So that your broom, you don't want it there. When wildfire is threatening, you take the broom inside. If you have combustible siding and it extends down to that non-combustible deck, then you want to either replace locally the siding to minimize the opportunity for ember accumulation to directly ignite, or you want to make sure that you don't have debris accumulation against the wall. And you can use the flashing detail that I'll show you in a minute here. So if you have non-combustible walking surface, then these are the ember exposure in terms of accumulation at the wall of things you want to be looking for. This is the lower right-hand picture is a spaced deckboard walking surface over a livable space. In this case, you have a deck that is sort of built on furring strips or sleepers and set on top of a roof covering. In this situation, you can have buildup of debris under this kind of a deck. You can have embers entering under the deck and igniting that debris. So you can have a flame impingement exposure to the underside of the deck, and then spreading to the house that way, either by breaking glass in a window or igniting combustible siding. There's a number of ways that this can be vulnerable. You need to keep debris from underneath the deck. You need to clean debris from in between deck boards because embers can collect in this gap. You can close up the gap, but then you have more of a moisture problem, particularly with wood deck boards. So that's why, and shrinkage and swelling, deformation, warping issues. So that's why you have this gap here. It can accumulate debris and accumulate embers, but it's there for a longer-term performance issue. So these kind of decks, and then we just also have normal kind of deck issues that might be overhanging your property. We have the same on the right-hand picture, ember ignition of broom. It's a bigger deal if it's near something that's combustible, or if it's on combustible decking, then the fire can spread, or if you have a lot of debris, additional debris accumulating. So wildfire threatening, these kind of combustible things go inside, You can take your propane tank from your gas grill and take it to the curb. We don't suggest you bring that inside. You can stuff underneath the deck that might, that could be ignited. This is a wood pile, and then we have this on the lower right-hand picture. We have a situation where you could have direct ember ignition just from embers accumulating at the base of this wall by itself, either of the combustible decking that we have here or the siding that we have here. This is a framing member, so that could also ignite. And you need to just be observant of any debris that's accumulating either between deck boards or at the edge of the house, of the siding. And so, this is a little bit repetition, so you don't really want to be storing your local lumber yard under your deck, and you want to have it more look like the lower right-hand picture. This is a Colorado Springs picture. This is a really good example of a non-combustible zone underneath a deck. This is really what you want to aim for, not anything like the upper left-hand picture. This is, again, Colorado Springs. If you have an overhanging deck over a timbered or forested area, really what you want to have is a fuel management scenario where you have tree spacing and removal of ladder fuel so that you don't have crown fires that we had in this particular situation. You end up with the same underdeck flame intensive exposure, which is really hard for most decks to survive. Some people want to utilize a deck enclosure scenario so that you can be less picky about the veg management downslope of a deck. If this is a non-combustible material, then potentially that would work as a strategy. If it weren't, but if you have a space deck for deck, then as a walking surface, then rot and the supporting structural members and corrosion of joist hangers and other connectors are going to be the problem that this deck will see, and you'll have deck failure for another reason than what you might have expected. So you need to allow for drainage and drying if you're going to take this approach. The veg management, fuel management is more straightforward and sure thing, let's say. We haven't talked about deck boards so much. Here we have a demonstration that I did when I was with the University of California. There's 3 deck board types. These are all nominally combustible materials, but you can notice that there's difference in performance between these 3. The far right deck is a wood deck, it's redwood in this case, and the middle deck is a wood plastic composite, as is the far left deck. All of these decks started with an exposure of a burning B brand placed on top of them next to this gypsum wallboard backing. So you just wanted to look at the deck itself and not have much contribution from the siding, the back wall. 35 minutes after these 3 brands were placed, the redwood deck was pretty much out. This particular middle deck was pretty much out. The far left deck was a much bigger fire. The difference in these products were that the middle deck and the far right deck, they comply with the California requirement for decking on decks built in wild and urban interface areas. The far left wood plastic composite deck does not. So these are all combustible products. There's differences in performance, and the use of the California requirement allows you to discriminate performance of the nominally combustible things. So if you're going to have a combustible deck, we suggest that you use the California products that comply in California as a guide to how you select the deck boards. And then just a little bit to talk about this clearance issue that we saw back with the chimney chase picture. If you have siding going all the way to the ground or all the way to the roof, you're going to have the potential for direct ember ignition even without accumulation of debris. You want to have some sort of clearance of a non-combustible material so that this doesn't happen. If you can't lift it up like the roof, then you can look at use of a non-combustible metal flashing. Just make sure you tuck it under at a lap joint so that you don't have water and embers getting between the metal flashing and the siding product. So I want to thank you for that question. Hopefully it answered it well enough. And I want to thank you all for coming and attending this webinar. I really appreciate the opportunity again to do this for NFPA Firewise. And if you have my contact information there, you're welcome to contact me if you have any additional questions. So thanks a lot.
Hey, Steve, you did so great on time. Would you mind if we take a couple of questions in addition to the ones that you answered from Bill, Tom, Jim, and Randy?
Sure. I didn't realize, so we're
did get it.
time. That's fine.
Sure. Okay. Yeah, we still have enough time that we can at least do one, and then we'll look at time again after that. Our first one is from Mike Frost, and Mike is one of our attendees, and he's asking, are roof sprinkler systems effective in preventing ember fires, and how much water is required?
So what was the last part? What kind of water? What about the water?
He just wants to know how much would be required. He's asking first if those roof sprinkler systems are effective in preventing ember fires, and if they are, how much water is required.
Okay, how much water? Sorry. So I think they can be effective. I think it's hard to argue that they won't be or couldn't be. The amount of water, I think if you're going to go that route, you need to make sure that you have a standalone system, because likely if you're on municipal water or similar, it may not be available to you. The electricity that you might want to pump it won't be there necessarily. So you need to have a sort of a standalone, either pressurized system or running on a generator. There's a number of commercial systems out there. I've seen some homemade systems. I think you want to make sure that you get drop size, drop foot, and I can't give you any particular information right now, but we can talk about it offline if you like, to make sure that the wind which will typically be present in wildfires doesn't blow it hither and yon. So, I think you see a lot of systems out there. I think what is missing actually is any sort of verification of how it works and how well it works, given the wind scenario and that can be present. I can know from experience that we have a water curtain at our lab, and to stop embers that from going outside the test chamber, and the water curtain stops a lot of embers, but not every single one of them. So it's not really a perfect system, and we often we would recommend that you take other precautions first, such as creating a non-combustible zone, using a Class A roof covering, and being diligent about removing debris from the base of walls and from gutters and the like. I think it's a much more surefire way to provide the protection of your home.
Thanks, Steve. We still have enough time that we can take at least one more, maybe two more. So the next one is from Judith LaRosse Cook, and she's asking, where are the California deck performance ratings posted? Can you refer her to where she could go look at those?
I sure can. Thanks for the question, Judith. We met a number of years ago, but anyway, nice to see you on the webinar. So you need to go to the Office of the State Fire Marshal's website, and if you just do a search on California Office of the State Fire Marshal Building Materials Listing Program, it'll take you to a spot where you can look up the products that comply. Judith, you had my email here, and actually, it would be useful. I can send a slide to you, Kathy, and you could insert it into this presentation. There's a little bit of a trick because you have to enter the right kind of term for the deck board for the California requirements, and then you'll get a list of them. But once you know how to do it, it's very straightforward, and it's on the building materials listing site. So send me an email, I'll send you a link and the directions, and I'll be happy, Kathy, to send you the same information you've inserted into this presentation so others can see it.
That was great, thanks. Steve, I think we have time for at least one more, maybe two more. The next one is from Dudley Carlson, and he's asking for your thoughts on the type of vent protectors that close when heated to keep embers out, and if you could just mention a couple of pros or cons on your research on those vent protectors.
Okay, so thanks, Dudley. So there are three vents, let's say, that have been designed specifically to reduce the intrusion of embers and flames. And I use that language because that's the language in Chapter 7A of the California Building Code that applies specifically to new construction in wildfire-prone areas. Because that language is put in, it induced individuals to design and build and sell these products. Up until a month ago or so, there wasn't a way to compare the performance of these products, but there, as of a month ago, there is now an ASTM, an American Society for Testing the Materials standard test method to evaluate the performance of these vents. So you can be looking for these manufacturers to show you how well they do based on a consistent test procedure. So you'll be able to compare product A to product B because they will have to test against each other in that sense if they want to be selling them to California anyway. So we incorporated these vents in our recent studies. And they each have different design features. So the one that you mentioned also uses a screen in the design to minimize the intrusion of embers. The coating that you mentioned that closes up when heated, that's really for the flame impingement part. We haven't finished our analysis of these vents yet, so I'm not really ready to talk about our findings, but they will be coming out directly, and we'll be able to compare the performance of the vents to standard mesh screening. It's a little bit too early to talk specifically about what we found out about them, but you should be looking for results from the standard test method, which they will be doing, I'm assuming, in the next not too long from now.
Steve, thanks. I can't thank you enough for participating today and being our Ask an Expert. I'm sure the audience got a lot of great information. We are finishing almost exactly on time, which doesn't happen very often. I just want to remind folks that the recorded version of today's virtual workshop is going to be available on our website at www.firewise.org, and that after the workshop today, you can register for the August 19th workshop, which is going to be on mulch combustibility and choosing the right type for your wildland urban interface home. And as a reminder that we only have 100 openings for each workshop, so if you're interested in the August topic, which we're lucky enough to have Dr. Quarles be our Ask an Expert for that one, also make sure that you pre-register. And we thank you all for participating today. The questions were great. It's your participation that gets the information out there that you really are wanting to know. So on behalf of Steve and myself and NFPA and the Firewise program, we thank you for participating.
Thanks a lot.